Hi, I'm Clark on Temptress. Today we're going to look into the Powerwin 200 amp hour battery and see how it holds up in our list to find the best inexpensive lithium iron phosphate battery around. Today we're going to look into the Powerwin 200 amp hour battery. I've been doing a lot of battery reviews and I realize I've been kind of creeping up in features. I was talking about the whole thing of this theory is let's get to basics and try to find the cheapest good batteries. Well, at the time that I okayed this was the cheapest 200 amp hour on Amazon. It's still quite cheap. Let's look into it. If you've been watching my videos, you know that I developed this BankManager. Now the BankManager lets you mix lead and lithium. It's the only way I've found that charges lithium properly. We'll be using it in the video today. In doing that, people have asked me, hey Clark, I want that. I like that theory. I like that how it works. What lithium should I buy? Well, I didn't know, so I'm doing this series so that I can know. And this battery is a nothing special battery. It doesn't have the bells and the whistles, no Bluetooth, none of that. But it's really, really, really inexpensive. It's kind of what we're after in this series. So let's take a look at this battery deeply. We'll start out with its specifications. The weight of this battery is 45 pounds. 45 pounds is the right weight for a 200 amp hour battery. I'm sure that it's got the right stuff inside. The price of it is, well, it's this as of the day we publish this video. We found that if you use the link in the description below this video, you're going to get a $50 coupon. Make sure you click on that coupon on Amazon, and that'll bring the price right down to kind of where the other batteries of its size are, the other cheaper batteries, that is. The width from the full plastic seems to be 21 inches or 53.5 centimeters. The width is 9 3/4 inches or about 25 centimeters. And the height, and I only measured to the deck here, so add some space for your wires, just under 9 inches, so that's like 22.5 centimeters. It's a little wider than the other 200s I've seen, but not wildly out of oversized. We'll know more when we look inside. Remember, we don't want them to use just whatever case and jam it full of foam, because we don't want to be storing foam in our boats, right? We want to make best use of the space. Okay, let's dig into this thing. What we're going to do in this video is first we're going to disassemble the battery. I'm going to open up the case so we can get access inside, see what's going on. Then we're going to charge it up with the BankManager to 100% by the BankManager's definition. And then for the one time in this battery's life, we're going to overcharge it. We're going to charge it until the BMS says uncle. Not good for batteries. Don't use the BMS for charging, but we need to do that once to see if the cells are all balanced, to see what cell might be a problem. We're going to learn a lot by that. Then we're going to put it on a big inverter and we're going to draw some real power through it. We're going to look at it with thermal cameras and we're going to see if any bit of it gets hot and how it performs under heavy load. Then we'll charge it up again with the BankManager to that 100%. I'll do a long, slow discharge off camera into a calibrated discharge device, and that will tell us how many amp hours, what the real capacity of the unit is. Then we'll talk about our final thoughts and place it on the leaderboard where it deserves to go. Okay, I cracked the case open. Oops, almost forgot my watch. Can't have metal on you when you do this. It was easier. These have been getting harder and harder to open, it seems. They've added some kind of little plastic retention clips and stuff. This shouldn't really matter for you guys because, you're not going to open the cases. But I got to say, for me, it makes life easier when they're easier to open. If you ever have to do maintenance inside your battery, these things don't have to be like bonded for life. The straps are connected to the bottom of this style case. So picking it up, all the weight is on the bottom. It's like a bucket. Just doesn't have to be so solid. But let's see if they did a good job. Okay, I see why it was easy. They didn't put silicone on the ends, only on the sides. It's not a good idea. We don't want, when pressure changes, we don't want the ambient air going in and out of the battery. Now, it's not happening a lot because this thing smells like a Chinese factory, so it hasn't exchanged a lot of air. It might be adequate, but you see the deal. We really don't want the salt water that we live around to be getting in and out because, you know, it'll affect things. Let's take a look. Okay, get that out of our way. Okay, well, that's disappointing. In their specifications, they don't like expressly say how many amps the BMS can pass, but they certainly strongly imply that it's a 200 amp BMS. It's a 200 amp hour battery. That's different. That's how much capacity it has. It can produce anything you want to multiply, but like 200 amps for 1 hour, for example. Except this one couldn't because the BMS is plainly labeled as a 100 amp BMS. They also, in their advertisement in one place, very explicitly say that it can produce 2,560 watts. Not watt hours, but watts. So watts is the flow of power, where watt hour is like the capacity of power. Saying 2,560 watts, since this is a 12.8 amp battery, do the math, it comes out to be, they're claiming that it can produce 200 amps. Well, it can't. This is not that. So that's disappointing. Is that a real problem? Probably not. It depends on what your needs are. Now, if you're going to draw more than 200 amps, or you want to, like running a microwave or a heat gun, and you're using this as your only battery in your system, you're going to fail. It's going to overheat in the BMS, shut down. It's going to protect itself, but that's not what you want. If you're going to buy 2 or 3 of these, then it's 100 amps per battery. That would get you 200 or 300 amps. That's enough for me, as long as it's enough for you. The batteries themselves should be charged at nothing over 100 amps. That would be the 0.5 charge rate. And this BMS should be able to let them charge at 100 amps. So it's fine for charging, but it's what your requirements are. I see they've built this box up. Usually they jam foam in because it's like the cheapest way. And they built a custom galvanized steel structure to hold the cells in the center. Oh, probably points for effort because, you know, that was harder for them to do than doing it with foam. I'd say it probably has some advantages. What I don't like is that they've wasted a lot of space. Instead of building this complex structure out of sheet metal, why not just order a smaller box? A box that fits the cells. We're having to store all of this air in our boat, and we only have so much space. You want to impress the buyers, make the battery box fit the battery that's in it. Try to give us the lowest volume possible. It really, really will help our lives. And I personally would buy smaller batteries that I can put 3 in instead of the big ones where I could only put 2 in. I'd be happy. The wires are 8 gauge. There's 2 of them in all of the paths. They're pretty short, of course. For a 100 amp BMS, I think 2 8 gauge wires are going to be fine, but we'll know more when we load this guy up and put the thermal camera on it and see what happens. Well, what do we have? We've got, the BMS has its normal wires that go to the intercell positions to tell the voltage of every individual cell as it needs to. That's fine. It has a remote thermal pickup that goes down to the battery itself. Very often on these really cheap ones, they just rely on the temperature of the BMS itself to shut down. So that's a good feature. That's definitely something in its positive direction. Let's see what we can find from the cells. They look like new cells. They claim to be A cells, but you know, claims are claims. But they certainly don't look like used cells. They look nice and bright and shiny. They're certainly lithium iron phosphate. I'll try to read what the cells say. CB52E8B2B. And then the rest of it I think is just serial number. And there's a lot of numbers there. So I think the top one is the important number. Okay, I've decided what I'm going to do. I'm going to put the battery back together to do the rest of the studies. I put these jumper wires on the 3 bus bars that I can't get to from the outside. So I can now look and when the battery's active and see what's happening in the cells, and we can learn what cell's doing what. So let me put it all back together, hopefully without starting a fire. Okay, that was a lot of work to be able to see the top of the cells. But we want to see the top of the cells. And they do look like new cells. They claim they're A cells, and we either trust that or that we don't, but probably. Let's now look at all the voltages of the cells. Now remember, I put my little leads in there so we can look at each cell individually on this meter. It's a fluke meter. This one's steered me really right as far as accuracy. We're going to call this cell 1, 2, 3, 4, from negative to positive. Cell 1, 3.379, 3.38 volts. Cell number 2, 3.377 volts. Cell number 3, 3.395, 3.396, so quite a bit higher. And then finally, cell number 4, 3.397, 3.398. That doesn't really mean much because when the battery isn't right at its ends, the cells all stay around the same voltage anyway. We're going to now overcharge this. We're going to charge until the BMS shuts down. It should shut down when it sees the first cell hit 3.365. But we'll find out. We're going to learn a lot. So let's do that. And I repeat, this is not how I like to see batteries charged. I think BMSs are there to keep the batteries from going pop, from wildly overcharging and dying immediately. For long life, you want to charge them to 100%. That's the beginning of that hockey stick of voltage if you've been doing research. And really the only thing that can do that in a live system is a BankManager. Okay, let's charge it up. I've got a bench power supply I've rigged into Temptress's batteries here. And we're gonna hook that up and charge it well, let's see what we charge at. Okay, we're charging at 4.999 amps, which is kind of the limit for this power supply. And we're gonna watch the voltage as she comes up. Let's just kind of watch the whole system voltage here for a while. 13.69 and going up. I charged this with the BankManager to 100%, but last week, so the voltage kind of slumps down a little bit. If we would have checked that first, I should have. It should have been 13.3. Imagine it was. Anyway, she's coming up pretty fast because this is a fully charged battery. When it gets to the point where the BMS shuts down, we'll notice because suddenly amps just won't go in anymore, we will go through the cells very quickly and get a tally of which one is high, which ones might be low. Hopefully they're all right close to each other, but if there's outliers, we want to know about it. Okay, I've been watching this for a while. Voltage is coming up. We're at 14.13. We're in that hockey stick where things start happening faster. I've peeked at the cells, and I found that the number 4 cell is the highest one. So we're going to switch the monitor now and watch the number 4 cell alone. And it is already up there ways. It's 3.61. Usually BMS is shut down when the first cell hits 3.65. So 3.62, 3.63 almost. Soon as that clicks out, I'm going to run right down all the cells and get their voltages really quick. We'll put them on the board, figure out the total, and we'll know at what voltage this thing shut down. Still taking 5 amps, 3.63, 3.64. I'm going to actually slow down the amp delivery a little bit here. Let's bring it down to 2.5 amps. Just so I have more time to react. Okay, I decided to do something. I slowed down the charge rate a lot. And we're down to a 1/2 amp of charge. Because I had a theory, and I'm really glad I did it. Turning down the charge rate, the voltage in number 1 cell is actually going down. It's actually going lower than it was. So I got my meter here, set it for amps, clip on, calibrate it as close as we can to 0. And then I'm going to clip it on to the sense wire that goes to the first cell. And I'm seeing over 1/10 of an amp. Well, that can only mean one thing. This battery is discharging the cell that is the highest voltage. And that's great. That's its balance working. Okay, the voltage just went way up, so I got to figure out what's going on. Yeah, while I was talking, the BMS shut off. So it hit its limit. And I should now run through these real quick. So what do I get? The overall battery is at 14.04 and going down. Cell number 4 is currently 3.564, 3.537, 3.462, and cell number 1, 3.468. So these two cells up at this end are at the highest voltage. One of those caused it to flick out. And the good news is we had some cell balancing. For those of you who own BankManagers, I'll probably put this in the manual soon. Periodically, you ought to let your BMS do a balance. And how you do that with a BankManager is set the BankManager from charge to 100%, where it normally should be, because that's the best thing for the batteries. But every occasion, like a couple of times a year or whatever, take the BankManager and flip it over to charge to volt mode. Choose a fairly high voltage. Charge slow. Slow could be putting a towel over your solar panel. And let it charge up until the BMS shuts down. Try to hold it up, like when you find out what voltage the BMS shuts down at. Bring it all the way down, use it the next day, do it again, but hold the voltage below that with your charge controller. And let it stay at some high voltages, and then kind of nurse that up. When you get it to anywhere near 14.6, your battery's in balance, all is well. But do that occasionally. We, by the way, are up to 14.45 volts now. Still going up. I'm going to lower the charge rate a little bit so we have more time. I'll take it down to 2 amps. And then, of course, once you feel that your batteries are nice and balanced and you're done with that, put the BankManager back to charge to 100%. In charge to 100%, it won't be going up into that hockey stick. It won't be stressing the cells. It'll be doing what lithium needs to do to have that long life. And, you know, you've used it for a while by now. You know that it does a lot of good things outside of that. So how this passive balancer works, I have another video on how active balancers work. They actually take power from the high cell and move it to the neighbor cell. This is a passive balancer. It just puts a load on the individual cells, just puts a resistor across them. Given time, it's a perfectly valid way to balance cells. And this BMS is doing it as far as I can tell. I shut down the current, so now it's at 14.46. And coming up again. The harder you charge, the more it pushes the voltage up. But we're trying to do this slowly, partly to get an accurate number, but also I'm kind of giving the BMS a chance to clean things up. Battery balancing takes a long time. In this video, there's no way I'm showing you every bit. There's going to be a lot of cuts. But just know that the voltage is changing very, very slowly, especially now that I have it down to 1 amp of charge. I'd like to show you a proper representation, but then this would be a 2-hour video, and you know you wouldn't have clicked on a 2-hour video. It's like watching paint dry. It's something you'll do for your own batteries, but you don't want to watch this on YouTube. Should we be aiming for perfection? I don't know. We know that this BMS does balance the cells. So given time at elevated cell differences, it should be cleaning everything up. And we saw that when we put the clamp-on meter on. Is there a way, without looking at the individual cells, that we can tell. There isn't. It just looks like there isn't. If you want to know if your cell is in good shape when you get it, the only real way is to either open the case and do what I just did, or pay a few extra bucks and get one with a BMS. If you watch my earlier videos, I'm all negative about BMS. I'm saying the cells don't care. I'm realizing that if you want to know the condition of your cells, you want to know if they need a balance, there's really nothing that can do that for you but seeing the cells. So short of them giving us 5 fused pins that come out of the case that we could test, the only way to tell from the outside is to spend the extra and get a battery with a BMS. Is that critical? No. This battery is going to work great. If I didn't know what was happening, I didn't know it was out of balance, it'd be fine. Even knowing that the cells are a bit out of balance because of the test I did with the clip-on meter, I'm perfectly confident that this battery and this BMS will sort itself out given some time. So what's my opinion? Well, I hate to say it, but pay a little more, you get a feature that's worthwhile. Don't pay a little more, you're a little bit more in the dark, but you know, sometimes ignorance is bliss. And this BMS, though it is not as big as what they advertise, does seem to do what a BMS needs to do. So, kind of like it. Okay, that's about it for there. Now, I'm going to do the next thing on the list. I'm going to bring, this time, an inverter to the table and hook it up to this battery and run some 100 amp load on it. And we're going to see if anything gets hot and how it works. Why I'm bringing the battery to the table is I've been using a cheap high frequency Chinese inverter. And honestly, it works great for all our needs. But I've been really hitting it hard on these battery tests, especially some of these batteries that can really like push 250 amps. It's not doing well. It's overheating a lot. I think probably it just needs new thermal paste. But I want to do some experiments with Victron equipment. So I've just bought a Victron inverter. I'm going to rebuild Temptress around the Victron inverter. Well, until I put the Victron inverter into Temptress, I'm going to put it right on the table so it'll be easier for me. Let me get set up and we'll get back and we'll push this hard. I'm all set up now. Let's start running this thing hot. Got my inverter there. It's currently, the voltage is 13.66 coming out of the battery, and we're drawing 2 amps. So apparently this Victron draws a good chunk of power all the time. Oops, can't have that open. All right, I've got it hooked up to this heat gun. Now I'm going to turn it on, and I'm going to bring the heat gun up to about 100 amps. Okay, we're in the high 90s. Now, I'll take my FLIR camera and take a peek in here and see what we can see. Oh, everything's warming up, but we got to have it warm up a little bit. Just out of curiosity, there's the heat gun. Okay. So the hottest thing is this terminal, but it's not very warm. 40 degrees. The wires are like 37 degrees for this warmest one. I mean, that's not even warm. The room itself is like 27 degrees. Anyway, we'll let this run for a while. Nothing's really hot. 40 degrees is barely warm. The other important information is what did the battery voltage go down to with the rated load? This only went down to 12.8. That's a really good number, and it would be a great number except for the fact that it's a 200 amp hour battery and we're only drawing 100 amps because of the limitation of the BMS. So I really wouldn't expect its voltage to go down too much. On the other hand, it's not making any heat. The jumpers are nice and big and they feel cool to the touch. It's actually a fine battery. And if you don't need bigger than 100 amp BMS, like if you're going to run 2 of these in parallel, it's looking like a fine battery from this point of view. I'm going to let it run for a good 15 minutes and then I will come back and we'll see what happens. Okay, that's 15 minutes. The footage you just saw, the thermal footage, was actually done just a few minutes late, so you'll see just slightly higher temperatures than what I was saying. That's because I forgot to push the record button. Anyway, this will be fresh data. Here's the record button. Lots of people have asked about my camera. It's a FLIR 1, and they sent me the wrong kind, so I have an adapter cable. It's a pain to use this way, but I really like it. It's a nice little camera. And what do we have? After 15 minutes, it's still at 12.8, 12.78 volts. It's been running 100 amps the whole time. There's a 48-degree place. There's one 50-degree spot right here, but that's maybe not tight enough on the contact. Oh, here we go. The hottest spot is 51 degrees, and yeah, it's warm. But I can hold my hand right on it. It's not that hot at all. This thing really is running remarkably cool. And the voltage is staying very high. But remember, we're only drawing 100 amps and it's a 200 amp hour battery, so we're only drawing at 0.5 C. It's kind of, I guess, as expected, but I have no complaints. I think thermally this thing would run until it's dead. The wires are adequate to its needs. Everything's running good. So let me turn that camera off. That's it for that part of the test. Let me turn this off. So now I'm going to put battery back together. I'm going to put the BankManager back on it, charge it to what the BankManager says is 100%. Then we're going to put a calibrated discharge on the device and bring it all the way down to 0 till the BMS shuts off again. I will report how many amp hours it draws, and then we'll draw our conclusions. See you for my time, like in 2 days, your time, seconds. Well, I'm back. I charged the battery up, and then I did a discharge through this thing. This thing's junk. It failed. And here's its brother, who failed like a month ago. I have none left. So until an order comes in for something similar, I can't do discharge studies. So I'm sorry, this one's going to get an asterisk down on the leaderboard because I don't know its capacity. There's nothing about this battery that makes me think it's not functioning well. I did get about 150 amp hours out of it before they failed. I'm going to give it the benefit of the doubt. Looks like it probably worked. But I apologize to you, I just can't do the study. Better to report that I can't do it than make up numbers, right? Okay, let's see how it lines up with the other things. Now, like all of these videos, if you go down to the description, you're going to see something called the leaderboard. If you're looking to buy batteries, you really want to click on that leaderboard. It has all the batteries and how they compare to each other and links to where to get them and links to the reviews I've done on them. So if you like this one, you go down and say, hey, I like the Elefast a little better. Maybe you should be getting the Elefast or Redodo or whatever. But let's compare this. Remember, this battery is entering the competition with kind of different rules. This is one of those cheaper batteries. So we're not expecting all the bells and all the whistles. But let's see how it lines up as a cheap battery. The capacity, I just have to give it a good with an asterisk because I can't tell. But I see no reason why it wouldn't have 200 amp hours. Generally, all the cells have what they're claimed to have. The only time we found ones with failing was when the cells were actually in bad shape. So we're going to give it a good just because of my failing. The cells themselves, I'm going to give a great. They look nice. They are obviously new cells. They claim to be A quality by the manufacturer. We can only go by that. I can't tell. The cells arrived a little out of balance, and that's been kind of typical for the Chinese batteries. What I'm really impressed with this one is when I brought it up to the higher voltage where it's supposed to equalize, I actually saw evidence of it equalizing. So I'm going to give the cells a great. Build quality is good. I can't give them an excellent or a great because they claimed in their ad that this was a 200 amp battery. They claimed that specifically what I saw in the ad was that it will put out 2,560 watts. That would be 200 amps. It is a 100 amp BMS, so it can't put out more than 100 amps for more than a few seconds, and it can't be charged at more than 100 amps. If that bothers you, if you need to draw more out of one battery, you shouldn't get this battery. But if, on the other hand, you're going to put a bunch of them out there, it probably doesn't matter at all. So, build quality, good. The case, I'm only going to give it a good. They did not seal these two sides with silicone. It would have been so simple for them to do it, and then they would have a hermetically sealed case. Now they've got one that might breathe a bit. Does it really breathe? I don't know. It smelled like a Chinese factory, so it hasn't moved a lot of air since it came to me. And it's been sitting here on the boat for, I don't know, 3 weeks, so it would have had time. I don't particularly like that it's such a big case for an only 200 amp hour battery. I'd like to see them use a smaller case that the cells just fit in, because our space in boats and in other places is so much more important to us than most anything else usually. I'd like to be able to put 3 of these in a space instead of 2 of these in a space is what it comes down to. So the case, I'm going to give them a good. It's a fine piece of plastic, but they could do better. So the company, I'm going to give the company, well, not full marks. It's the company that puts out the ad, and the ad was deceitful, right? You know, it said 200 amp hour BMS, and they gave you a 100. If you didn't take the case apart, you would assume it's a 200. You'd crank it up, and it would start shutting off on you. Well, we don't want to have to go through that. So I'm going to give the company a good. Cost value at the time of the video, I'm going to give it a great. That's what this battery is really trying to be after all. It's not Bluetooth. It's not all of these bells and whistles. It's just a lot of battery for a little bit of money. And of all the 200 and bigger amp hour batteries we've compared, it had the best price per watt. And that's what you're looking for if you're looking at this battery. When you get the 100 amp hour batteries, they are a bit cheaper per watt because they basically sell a lot more of them. But that means a lot more joiners, and you're mixing a lot more batteries. So if you want to build a bigger bank, you kind of need to start with bigger cells. And this might be the cheapest way that's on our page. So would I buy this battery? Yeah, if money was very important to me and I really didn't need the other features, I'd probably buy this battery. I think it's got a decent BMS for its size. I would buy this battery particularly if I wanted a lot of battery in my bank. If I wanted 800 amp hours in my bank, for example, 4 of these is so much better than trying to put 8 100 amp hour batteries in. Partly because that's just too many batteries and they're not all seeing exactly the same world and they can get out of balance. But also, you know, we're talking about money. Those big jumper wires, they cost a bunch. You get enough to do 8 batteries. It's pretty expensive. So this might actually even be cost effective that way. So if I wanted a lot of battery, this is a good building block for an inexpensive system. Thanks for watching the video. I hope you enjoyed it. If you have a friend that might be buying some batteries, please share this video with them. Nothing helps us more than sharing the videos, subscribing, you know that. Liking is also very good. I appreciate you watching, and good day from Clark on Chemicals.